Hey everybody, welcome back to the calculation series. In this episode, we're continuing our journey into range calculations, cooktop calculations, in-wall mounted oven calculations. And if you watched part one of this series, it's real important, if you haven't, that you go do that, because we cover the branch circuits when you use the nameplate. What happens when you have a cooktop and a wall-mounted oven and you combine them to treat them as a single range? I know it's not a range, but you treat it as a range. We also examined some of the changes that are coming in the 2023 NEC versus what you see in your 2020 and 2017 when it comes to the notes underneath of table 220.55. Didn't change their intent, but it kind of expanded it and made it much easier to understand. So I'm looking forward to the 2023. It's just going to make it much easier to be able to read something. And again, that's the goal. We want to make it as easy to understand as possible. Now, again, we talked about how to do branch circuits. Now, in this part, we're going to get into calculating the loads using the standard method, which utilizes 220.55, the table. Remember, because if it's the optional method, you just take the nameplate, okay? If it's the standard method, you're going to use 220.55, and you might be using the standard method to size feeder to an individual dwelling unit. You might be doing the optional method, but if you're using the standard method, you need to know all about 220.55 and the tables, and as well as those notes that are underneath it, okay? Also, the importance of watching part one before you watch this one is because whether you're doing the optional standard method for the load, it has no relevance to the branch circuit sizing. In that video, we talked to you about how to size the branch circuits for those various cooking equipment loads. So that's why that one's important. All right, with that said, let's go on and get into this one and get into the presentation. All right, so we're going to be doing a deep dive into table 220.55. We're going to be looking at a lot of examples. We'll go back and forth into the code. I will probably use the 2020 edition of the NEC because I don't believe anything is significantly changed in the 2023 for this table. And the notes, while they might have been renumbered, they're still very much applicable, and there's nothing dramatically needing us to go back and look at that. So for simplicity's sake, we're going to continue on with the 2020 edition. But if you're in the 2023 edition of the NEC when you watch this video, just know the same rules are going to apply. Okay, it's just added some additional notes, and really note 4 in the 2020 and 2017. In the 2023, it got broken up a little bit, so it's easier to understand. That's really the only change there. Okay, all right, so let's go on and get into it. All right, so fundamentals. We want to study some fundamentals here. Understanding how the table works, that's important. So calculating individual ranges. My question to you is calculating the demand load for the following ranges individually. I have a 9 kW range. I have a 10 kW range. Now, I'm not talking about all of these together. I'm asking you, what is the demand for each one of these? What would they be? If I had a 9 kW in my house, what would the demand load used in our load calculation be? Would you use 9 kW? Okay, that's what we're going to look at. What if it's a 10 kW range? What's the demand load? What is a 11 kW range? What is the demand load? What is a 12 kW range? What is the demand load? So it's pretty simple. We're going to go to 220.55, the table, and we're going to select the correct column A, B, or C. Okay, and select the number of appliances. Now, even though you see 4 here, we're just saying there's just one. We're not doing a multifamily dwelling here. We're just individually, we're going to look at each one of these. Okay, so let's go to the NEC. All right, and so we're going to look at the table, and let me go on and get over to that. So here's the table. We're going to be looking at it right here. Okay, 220.55. In fact, let's make it easier. Let me go on and go to that table rather than having to do an in view. That way it just makes it easier for you all to see what we're looking at. So here's our table, okay? This is what we're looking at. Now let's kind of, I'll scroll down a little bit for you. Let's kind of give a kind of a view of what we're talking about, the lay of the land here. So this is what you'll see in your 2020 edition of the National Electrical Code. Essentially the same thing in your 2023 edition, essentially the same thing in the 2017 edition. You've got this bold text about the table. Now, it's interesting. Let's read this real quick. It says, table 220.55, demand factors. So this is your demand factor. So in that question I ask you, I want to know what is the demand for those different ranges, a 9, a 10, 11, and a 12 kW range individually. So it says table 220.55, I'm reading the bold. Hopefully you got your code book, follow along. It says demand factors and loads for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances over 1 3/4 kW or 1,750 watts, in case you want to know what it was in watts. Ratings, okay? And then you notice it has parentheses. The parentheses say column C is to be used in all cases except as otherwise permitted in note 3, okay? Well, note 3 is talking about ranges that are going to fall between the 3 1/4 all the way up to 8 3/4. Well, all of our ranges are over that, okay? So we don't even have to look at note 3 yet, all right? We're just going to go to column C. So in column C, quite interesting, as long as it's not over 12, which our ranges aren't, I have a 9, and I have a 10, and I have 11, and I have a 12. Again, remember, we're not adding them together. We're not doing that yet. We're just looking at each one of these individual ranges and trying to find out what their demand is. Well, you see on the left, it says number of appliances. You go to the right, since all of our ranges fall under column C, because column B is for 8 1/2 through 8 3/4, and column A is for 3 1/2, okay? Less than 3 1/2, but definitely over 1 3/4, okay? So we're not in A, we're not in B. For these ranges we're talking about, we're commonly in C. So we have one appliance. Well, guess what? If it's not over 12, guess what the kW is for that 9 kW range? It's 8 kW. Guess what it is for that 10 kW range? 8 kW. Guess what it is for that 11 kW range? 8 kW. Guess what it is for the 12? It's 14. No, I'm just kidding. It's still 8 kW, right? Because none of those exceeded 12, okay? Okay, so let's go back to the presentation here, so the PowerPoint, so I can explain that. All right, so if you look at our example, no, it wasn't a trick question. Basically, 8 kW is what you're going to use for all of these because they all fall under column C, and this one range is 8. Now, if we were doing a calculation, and we will later, where we have multiple ranges, then it's a little something different. But right now, I just wanted to know what the individual rating was for each one of these ranges, and it's 8 kW. See how that works? Okay. Now let's stay in column C for a second. We're going to answer this question. What is the demand load for 30 12 kW ranges? Okay, it sounds like it's getting complicated. It's not. Just walk with me here. 30 12 kW ranges. All right, well, since they're all 12 kW, they're all still going to be under column C. No stress here. Since all of those are C, we simply go to table 220.55. We find the number of ranges and follow that all the way over to column C. So let's go on and do that in our code. So let's go on and do that with us. So we had 30 of them, right? So we've got 30 of them. Let's scroll down. And, ooh, we're right here. So, oh no, people are going to say this is making it complicated, right? We have this value here, and I'm not sure I can zoom in and get all this to highlight. There we go. So this is what we've got. And the first thing somebody say, Paul, why would you start off with one that's so freaking complicated? It's not complicated. What does column C say to do for 30 12 kW ranges? Remember, it's not over 12. It's 30. So I am in column C. So let's go back to the presentation and we'll work this thing out. But notice it says 15 kW plus 1 kW for each range. Okay, so let's go back and see what we do. It's not nearly as complicated as it seems. So it said 15 kW plus 1 kW for each range. So it's 15 plus, how many ranges do we have in our question? 30. So that's 30 kW. So it's 15 plus 30 equals 45 kW. That's your answer. 45 kW or 45,000 watts. But you know me, I'm working a calculation, so I like to get it down to VA ultimately. That would be 45,000 VA. And that's your contribution. Now, check this out. This could have been a multi-story building, right? It could be this is obviously, let's say, a 30-floor building with apartment on every floor. You didn't need to get complicated because it's the same way you do it, whether it's a single unit. This case, there just happens to be 30. And they were all 12 kW ranges. So this is the same thing. So when I'm doing the load calculation under the standard method, and I have got 30 ranges in my overall load calculation for that multifamily building, if I'm using the standard method here, then the contribution for that range load is what? 45 kW. And I simply add that into my equation, okay? Now, we're going to cover all this in my multifamily dwelling video, whereas I plug in some of these examples. But again, to be honest with you, when it comes to ranges, it's really just that simple, right? All right, let's do a little more. Let's get a little more complicated. All right, now, what is the demand factors for an 8 kW range? Okay, so we changed it a little bit, right? Remember, column B says 8.5 through 8 3/4. Get your code book, look at 220.55 in that table. But also, column C comes into play because it's not over 12. And remember that little parentheses at the top that said that in all cases you use column C? But you have an allowance in note 3. It says all cases use column C unless note 3 is applicable. Well, guess what? Note 3 is applicable here. What does it say in note 3? Well, here's what it says. Don't worry. I put it on the screen for you. It says, when it's over 1 3/4 kW through 8 3/4 kW, in lieu of the method provided in C. So that means you don't have to use C if column B or column A, whichever one you're using, results in a better value, then I can use that instead of or in lieu of the value that's in column C. But I still have to compare the two because, you know what? Column C might be the best answer still. And this is unique in the code because usually everywhere else, you take the greater value. But when it comes to ranges here, I get to compare and I get to take the lesser value. So let's look at it. All right, so column B is titled ranges between 3.5 kW through 8 3/4. Column C is entitled not over 12. Well, obviously this 8 kW range falls into both of these columns. All right, so let's kind of read this again now that we can absorb what that in lieu means, and then we can kind of get the picture. Over 1 3/4 through 8 3/4 kW, in lieu of the method provided in column C, it shall be permissible to add the nameplate ratings of the household cooking appliances rated more than 1 3/4, but not more than 8 3/4, and multiply the sum by the demand factor specified in column A or column B for the given number of appliances. When the rating of cooking appliances fall under both column A and column B, the demand factors for each column shall be applied to the appliance for that column and then the results added together. Okay, let me dissect this for you. In this case, we're doing a load calc, not like we did with a branch circuit. Here we're doing a load calc. So if I had a cooktop that falls under column A and I had an oven that falls under column B because of their kW ratings, then I get to apply the demand factors in percentage to each one separately under the column that they fall under, and then I add them together. Make sense? Okay. Just want to make sure you understand how we do that, okay? Now, column C is just going to say, all right, well, it's not over 12, so obviously I've got 2 appliances, a cooktop and an oven. That's 2 appliances. Then you go to column C under 2 appliances, and that's the kW. But the value might be less if we used column A and column B and we came with a total, and then we compared that to what column C says. I get to use whichever's less. Don't worry. Sounds complicated. It's absolutely easy peasy. So let's work it. All right, so in this case here, we're going to go to table 220.55 and determine which results is the lower value, column C versus column B. Now, one 8 kW range would be 8 kW under column C. Okay, and we can go look at that in the code. Let's kind of go to the code real quick and look and see what it says. So right here, obviously one appliance is 8 kW. Obviously it's not more than 12. So we're good to go. Now, under 3.5 through 8 3/4, you get what's called, notice this says demand factor in percentages, and over here it's the demand in kW. So this is the actual demand, but this is a percentage you multiply by. So in here it says 1 right there, and it says use 80%. So we're going to see which is better, column C or the 80%. Okay? All right, back to our presentation. All right, so in column 1, that range, okay, that 8 kW range would be 8 kW under column C. Okay, so you could use the 8 kW, but guess what? You're permitted, in lieu of that, to now look in column B, because this range falls under column B. Now, what does that say? Well, we saw it was 80%. So I get to take this 8 kW and I multiply that by 80%, and that gives me what? 6,400 watts, or 6.4 kW. Now, isn't that less than 8? Absolutely. So which one am I going to use? I'm going to use column B's result, which I'm going to use 6,400 watts or 6,400 VA as my load in my load calculation for my dwelling. That's the value I'm going to use. That's my range contribution load. It's just that simple, folks. All right, let's move it on. Let's make it a little tougher. Now, what if the demand factor is, and I do it this way so that you can kind of see where we're going with this. What if I'm doing a multifamily and now I have 6 of those 8 kW ranges? Now, you might be thinking, okay, this is going to get more complicated. It's not. Trust me. It's still using note 3. Still the same concept, okay? So, look at it here. We still fall under where? Column B, because the 8 kW falls between 3.5 and 8 3/4, okay? But it also falls under column C, because each of these individual ranges don't exceed 12, so it most certainly falls under column C, right? Makes sense? Okay. So we don't have to read note 3 again. We have a firm understanding of how that works. So in column C, if I was going to choose, they have 6 8 kW ranges. I'm going to go to column C because it says, first of all, I use that in all cases. I only get to use note 3 if it's applicable. Well, obviously it's applicable because my range, these ranges fall within column B. But we're going to go look at column C first, because I don't want you thinking that sometimes column C is better than column B in all cases, but you got to do the comparison just to see. So let's go to the code really quick and do that. We have 6 8 kWs, okay? So we want to look at it here. So we have 6 right here, 8 kWs, that is 21 kW, okay? Or 21,000 watts or 21,000 VA, however you like it. Remember, it's synonymous. kW is the same as kVA. Watts is the same as VA when you're doing calculations in Article 220. So in this case, that's be 21,000. So you're thinking, okay, is that the answer? I don't know. But since we fall under column B, we got to work that too. So what's our multiplier for that? Well, we have 6 of them, and we're under column B. So our multiplier is 43%. Okay? So that's going to be 43. We're going to do 43% of the full total VA. Don't worry. Let me show you how you do that. So we'll go back to the presentation. And so what we got to do here, we already got the 21 for column C. Maybe that's going to win. I don't know. In this case, we go 6 8 kW ranges. So we got 6 times 8,000 or 6 times 8 kW, however you want to work your math out. And then you'd multiply that by 43%. And that gives me 20.64 kW. Okay? Well, guess what? Isn't 20.64 kW less than 21 kW? Absolutely. So I'm going to go with column B. That's the value I'm going to use in my overall load calculation. And always remember that we can convert this into the watts by just simply taking 20.64 times 1,000. Okay? But you probably get the value here. You probably get 20,640. You probably already know how to do that. So anyway, that's what you do. So this sounded complicated, but it really wasn't, was it? All right, let's do another one. You want to get tougher? Okay, let's do this. What is the demand factor for one 3 kW range? And it'd probably be better off if I said 3 kW cooktop here, because I don't know of many 3 kW ranges. It's irrelevant, right? But let's say this is, we'll just go with it, 3 kW range or cooktop or whatever, oven, doesn't matter. And then you have one 6 kW range. Now remember, this could have been a 3 kW cooktop, and this could have been a 6 kW wall-mounted or in-the-wall oven. It doesn't matter. Doesn't matter. All right, now, let's see. So one of the things we're going to notice right away, remember what we talked about the allowances in the note, in note 3 and what we could do? This falls under column A, and it falls under column B, right? But guess what? These are two separate appliances. So we have to follow column C as well, right? And see and compare the two. Now, this differs from how we did a branch circuit. Remember, because in a branch circuit calculation in part 1, we added the 6 and the 3 together. Then we treated it as one, and then we went to the table. It's not where we do this because we're not doing branch circuits now. We're doing loads for our load calculation for our dwelling. So keep that mentality rolling. Remember, we're not doing branch circuits now. We're doing the load for the dwelling. All right. So under column C, let's kind of work each one of those. So we have a 3 and a 6. So we need to see what our multipliers are. So let's go to the code. So we have a 3 and a 6. So I'm going to go to the code here. And what do we got here? So we have one that falls under column A. So that's 3. So that's, let's see here. Less than 3 kVA, we're in A. And let's see, 3.5. Oh, wait a minute. Both of them follow B. We have a 3 and a 6. Right here. And so we have 80. And then we have 2 is, 65. Okay. So let's go back and look and see what we've got in our presentation. All right. So again, this one says 3 kW. 3. Oh, we got to go back. Let's go back to the code. We got to see because I think this one's going to actually be under A. Are we in the code? Let's see. Let's go back, see if we're in the code book. Yeah. Look at the code. We are less than 3.5. We are under column A, and we're under column B, just like what it said in our presentation. Sweet. What is the multiplier? Well, one appliance, 80%. Column B, one appliance, 80%. While we're here, let's look at those two together, 2 of them under column C. So go to the left under number of appliances, and we're going to be looking at right here, 2. It's going to be 11. Right there. So this is going to be a cool one, right? So we're going to see whether the combination of column A and column B gives us a better value than column C. And we're going to compare the two. Now, how do we get to do this? Again, that note 3 gives us the ability to do that. Okay? All right, so let's kind of see what we get. And let's go back to our calculation. All right, so under column A, we had 3 kW. And so 3 times 80% is 2.4 kW. Column B, we had 6 kW range. That is 6 times 80%. That gets 4.8. You add the two together. Remember it said add them two together in note 3. And that is 7.2 kW. Well, what was the value under column C? It was 11 kW. Okay, huge difference in your calculation that I can use 7.2 kW versus 11 kW. All right, now another interesting thing here is this is giving you permission in note 3 to do this. In the real world, if you didn't want to use note 3, could you use 11 kW in your calculation? Yeah, if you wanted to, but why would you? If I can use 7.2, why wouldn't I use that? When you're taking an exam, they always are going to want the best possible answer. And obviously the best possible answer here is 7.2 versus the 11. So just remember that as a little tip. Always solve for the best possible answer. Okay? That's a pretty neat one right there. All right? Let's do another one. What is the demand factors for 4 5 kW ranges, 7 8.5 kW ranges, and 9 3.5 kW ranges. Now, I'm using all ranges here, again, for simplicity's sake, but you could have a mixture. You could have 4 or 5 kW cooktops. You could have 7 8.5 kW in the wall-mounted ovens, and you could have 9 3.5 kW ranges. I'm just saying, okay? So this is asking us, again, how we do it. Now, usually in this, you might have a multi-story building, and they're different size units from efficiencies to 2 rooms, and you might indeed have different size ranges in each one of the apartments. I mean, it's plausible, right? Either way, you solve it the same way. It all works the same way, all right? So in this case, what do we got? All right, so first thing we need to do is going to determine what our sum is. So we're going to get these numbers up. So we're going to start adding them up. So I have 4 5 kW, so I'm going to do 4 times 5, that's 20 kW. Okay. And next thing I'm going to do is I'm going to add 7. So I have 7 times 8.5. That's 59.5 kW. And then I've got 9 3.5 kW. So I'm going to add those up. So that gives me 31.5 kW. So I've got total that many total. Okay. So I'm going to add them all up. 20 plus 59.5 plus 31.5. That gives me 111 kW. Now, quite interesting here is all of these ranges, okay? All of these ranges fall where? They all fall under column B, right? 3.5 and not more than 8 3/4, right? That 5 kW, that 8.5, and that 3.5 kW. They're all fall under that same column, okay? But we still want to compare it to what? We still want to compare it to C, right? So in this case, since all of these appliances fall under B, we can compare it to C. So let's go look at column B. So how many do we have total? Okay, there's 20 total, right? And we go down to 20. We need to find out what the multiplier is for the 20. And then we know what the total kW is. So let's go look at the code real quick. So we have 20 total. And let's just kind of go down here. So we're under column B. We go down to 20. Here's the 20, okay? And here we have 28%. That's our multiplier. Now, we could go down, again, there's a total of 20. None of them are over 12. And for 20 under column C would be 35. We want to see which one is going to yield us the best, okay? Because right now I'm at 111 kW, but I haven't applied any demand factors. I haven't applied that 28%, right? But 35 is a lot better than 111. Let's just start off by saying that. So let's kind of go back and see what we're doing. All right, so we take that 111 kW, multiply that by 28%, or 0.28 if you like to do it in decimals. Start from the 8 on the right, move 2 decimal spots to the left, and put that dot there. And that's 0.28, however. That equals 31.08 kW. Well, it was 35 for 20 under column C, but in this case, guess what? 31.08 kW is the winner every day of the week, and that's our load contribution for these ranges. Pretty straightforward, isn't it? Okay, don't forget, Note 3 permits this. Note 3 allows us to be able to use column B in lieu of column C, okay? All right, hopefully it's not getting confusing for you, okay? Next, what is the maximum factors for a 13 kW, what is the demand factors for a 13 kW range? Okay, remember, we're doing load calcs now. So in this example, the demand factor falls under column C because it is over 12. And it certainly doesn't fall under B or A, okay? So it's definitely under C. Now, one thing that you'll notice right away, column C says that it's not over 12, but this range is over 12. So this means we got to use some notes. In this case, note 1. So however, since the range in kW is over 12, we're going to use the note. And what does note 1 tell us to do? It says when it's over 12 through 27 kW ranges, all of the same rating, we only got one in this example. It says for ranges individually rated more than 12 kW but not more than 27, the maximum demand in column C, okay, and column C is the demand, mind you. The exercise that we're going to do here is using the value that's over 12 to come up with the percentage that we're going to multiply by the maximum demand in column C, and then we're going to make sure we add it to it. Sounds confusing, doesn't it? Don't worry, it's not. All right, now, it tells us the maximum demand in column C, and I'll remind you for one range in column C is 8 kW, okay, one range. It says, shall be increased 5%. So that means that 8 kW has got to be increased 5% for each additional kilowatt of rating or major fraction thereof by which the rating of individual ranges exceed 12 kW. Okay, sounds confusing, doesn't it? It's not. Trust me, it's not. So go to table 220.55. Now, we have one 13 kW range. Now, it says to increase the value, the maximum demand in column C by 5% for every kilowatt that exceeds 12. Well, how many exceeds 12? Well, it exceeds 12 by 1 kW because 12 to 13 is 1 kW. So note 1 tells us to increase that 5%. So we have to increase the 8 kW, which is the maximum demand in that table. We have to increase that by 5%. So what do you do? All right, well, let's kind of work that. Now, there's two ways you can do this. I could take my calculator. Now, watch how I do this. I can take 8, and I can do that times 105%, okay? And that gives me 8.4 kW, okay? So it already does that for me, all right? So I can do that, or I could do 8 times 5%, and it gives me the 0.4 that I can add to the 8. So depending on how you want to do your math, it's pretty simple, okay? So the reason I'm using a 105 here is because anytime that I need to increase a value by a percentage, then I can use 100 is basically, if I did 8 kW times 100, it's 8 kW. But if I did 8 kW times 105, that's increasing it by 5%. If I do 8 kW times 110%, then that's increasing it by 10%, and so forth and so on. A lot of times it's just as easy to do 8 times 5% and then add that value back to the 8, and that's how you would do it. It's pretty simple. Remember, we're still going to use the base that's in the table, okay, or in the column C. 8%, 8 kW for one range. That doesn't change. But we only have to increase that value by a percentage of what? 5% for every kW that it exceeds 12, okay? Remember that first exercise we did when we started this lesson? I had a 9 kW range, but it was still what? The demand load was 8 kW. Even if it was a 12 kW range, the demand load was what? 8 kW. Note 1 is telling us how to increase that value in increments of 5% for every kW or major fraction, okay, that exceeds 12. Now, what's a major fraction? Anything that's 0.5 or greater. That's a major fraction, okay? All right. So if it was 12.6, then it would go up to 13, okay? You get me? All right. So that's what we got, and that's the little tip right here. Notice how this demand load is 13.5. The math would have been 8 times 110% since it's 0.5 a major fraction. What do you mean? Well, so in this case, the 0.5 would have moved this up to 14. And 14 is how many kW above 12? 2 kW. And remember, it's 5% for every kW above 12. So that's 10%. So I would take the 8 and multiply it by 110%. You get my drift? I think you get it. All right? So again, don't forget note 1. And that's how you would do note 1. All right, so now let's go on and make it even a little more complicated. We're going to get deep now. Let's see, what is demand load for the following ranges? Okay, well, this one, we have 6 15 kW ranges. okay? And we have 4 10 kW ranges, and we have 10 9 kW ranges. So we're just using the term range to keep it simple, okay? It could be cooktops, it could be a mixture or whatever. We're just going to keep it simple. Now, the first thing we'll notice here, they're all unequal ratings. They're not all the same. First thing we notice. Second thing we notice, they're all over what? Well, they're all, one of them is over 12. The other two are not over 12, but they are unequal ratings. Also, they're not in column B, and I can't use column A. So we got to be planted in column C. Now, since one of these range sets are over 12, then we're going to have to do something, because how can we use column C? How can we do that? Okay, now we can do that in a comparison, but at this point, we're like, what are we going to do? Okay, this is when you're going to go to note 2. So take your time to read note 2, because this one takes a little bit of understanding, right, in working out. Now, you're still going to end up using column C. You're still going to do that. There's really no comparison involved here. You're only going to use column C, but I have to get there first. And there's a little exercise you got to do before I can get there. And I want to show you that. But before we get into that, let's go look at the code, because I want to read it. And so go to the code. I've got it here on the screen. I want you to go and look at note number 2 while I read this. Okay. Now it says over 8 3/4 kW through 27 kW ranges of unequal ratings. Yes, these are all unequal ratings. It says for ranges individually rated more than 8 3/4 kW and of different ratings, but none exceed 27 kW, an average value of ratings shall be calculated. Notice it says an average value. So just remember that, an average value of rating, okay, of ratings shall be calculated by adding together the rating of all the ranges to obtain a total connected load. So I'm literally going to add up every one of these kWs for every one of these ranges. You get me? Okay. And once I do that, I'm going to divide that by the total number of ranges. So it's pretty straightforward. If you follow this note exactly how it's written, then it's pretty straightforward. So we're going to do that. So when we do that, we're going to add them all up. Then once I do that and I determine what that average value is, then I forget everything I just did. And now I've got a range value to work with. And once I have that value, then I'm going to start doing my calculation. Sounds complicated, doesn't it? It's not. Now it says, note 2 says any ranges that are less than, okay, this is important. Notice it says use 12 kW for any range rated less than 12 kW. Now this is where, and again, then you divide it by the total number of ranges. Don't worry, we'll work this out. But this is where people get confused, because these are 10 and this is a 9. But when we're doing this calculation under note 2, you forget that that's a 10. You forget that that's a 9. You draw a line right through it. All of those 10 kW ranges are now 12 kW ranges. All of those 9 kW ranges are now 12 kW ranges. Yeah, exactly what you do here. So let's see what it is here. Let's work it. So here's what we've got. The 6 15 kW ranges, all right? So 6 times 15 is 90 kW. Now remember those 10s? We crossed it out and we now made it a 12. So then we add it up. The 4 times a 12 is 48. Remember those 9? We drew a line through it and now they're 12. So there's 10 of those times 12 kW. That's 120 kW. Okay? So how many do we have total? Well, we had 10, 6, and 4. That's 20 ranges. So the sum, okay, remember it said add them up, and the sum of those 20 ranges is 258 kW, okay, or 258,000 watts. Now, once we had that sum, we finished the first part of that note. Now it moves on and says, you know what? We got to get this average. How do we do that? Well, note 2 says we have to find the average in kW, a load, by dividing the total kW by the total number of ranges. Well, this was my total kW, 258. I'm dividing that by 20 because we have 20 ranges. And that is 12.9 kW. So what is the average? Well, the average is 12.9. Now, this is a good example of the major fraction rule here. Since it's 12.9, this is 0.5 and greater. That's a major fraction. So what are we going to do? We're going to round that bad boy up to 13 kW. Okay? Makes sense? Now, once we do that, right now, we're going to kind of pretend like just pretend like it's a single range right now, because we're just looking for this percentage. That's all we're doing now. We did all this to find a percentage that exceeds 12. Don't forget, we still got 20 ranges. We're just going through the exercises. All right, so now I'm going to ask you, how many kW for this average, how many kW does that exceed 12? Well, 13 kW exceeds 12 by what? 1 kW. That's 5% increase, right? So you went through all that just to find out what your percentage of increase is. Right? Sounds like a lot, but you went through all of that. Now what do? Once you know what you got to add and what the percentage is, it's pretty simple. You go back to column C, you go down to where there's 20 ranges, you go all the way to the right to column C, and you find out what the maximum demand is for 20 ranges. It's 35 kW, and you have to increase that, what? By 5%. So you take that 35, multiply it by 105%, all right? Or you could take the 35 times 5% and then add that back to the 35. It's totally up to you. Ultimately, it's going to be 36.75 kW. That's your contribution. Now think about this for a second. We added up all this stuff, even if we did use 12 instead of 10 or 12 instead of 9. We had a lot of load here, and now you're telling me that I can reduce this all the way down to 36.75 kW for my load calculation for the dwellings, for the multifamily dwelling? The answer to that is absolutely right. Because of diversity, okay? This is perfect. And they're not all going to be on at the same time. Oven ranges and all those, they cycle out. So being able to do this is a beautiful thing, okay? I'm just saying. It's a beautiful thing. All right, let's move on. Okay, now, this part gets into calculating the branch circuits individuals, and we don't need to do that, folks, because guess what? We've already done that. So hopefully you go back and you watch part 1 of this video series, and you will understand how to do all of these calculations. So hopefully you learned something in this 2-part series dealing with range calculations. Now, we're going to cover ranges a little bit more in depth when we get to multifamily dwellings, and it's going to be a totally different presentation for those. But I think what you saw in part 2 here today, it's pretty straightforward. As long as you understand how to use note 1 and note 2, and now you know how to use note 3, and in part 1, you learned how to use note 4, and the 2023 NEC, you learned that all the notes changed a little bit. They all mean the exact same thing. So hopefully you got something out of that. I hope you enjoyed this little exercise. If you have any questions, you can always reach out. We're more than happy to help you if the range calculations get difficult for you. Remember, if you're in our Fast Tracks program, it goes into in-depth. So again, hopefully you got something out of it, folks. Till next time, stay safe.